All right, we're on Unit 8, Lesson 1. We're talking about exponents and how we can use exponents to simplify expressions, solve equations, and then what prime factorization of a composite number is. So we've got some new vocabulary words: exponent, base, square root, and prime factorization. So as we go through the lesson, we'll talk a little bit about those. Okay, to start out with, the shorter way to write 6 times 6 times 6 times 6 is 6 to the 4th. The base is the 6 and the exponent is the 4. We've talked about those before, so I think you guys have that down. When a number is written like 6 to the 4th, you would say that it's written in exponential power, so, or exponential form. So 3 to the 10th power would be like 3 to the 10th. Okay. 4 cubed, well, cubed means to the 3rd, right? So 4 to the 3rd power. 8 squared, square is 2, so 8 squared would look like that. Okay. Count how many 7s there are here. You should find there are 5 7s, so this is 7 to the 5th power. Okay. This one's a little trickier. You've got 2 4s, so that's 4 squared times 3 to the 4th power. Okay, because there are 4 3s here. Just like this one will be 5 to the 3rd times just 2, because there's only one of them. So when there's only one, we don't put a exponent on it. Okay, so when thinking about simplifying, then we're actually just thinking about solving. So this particular one is like 2 times 2 times 2 times 5. Well, 2 times 2, 4. 4 times 2, right, is what we're going to do next, which is 8. Then 8 times 5 is 40. Okay, so 2 to the 3rd power times 5 is 40. 12 squared is like doing 12 times 12, which if you work that out, you would find it's 144. Okay, let's try one or two more. 1 cubed is like 1 times 1 times 1, which you should know is just 1, right? 1 times anything is just itself. 4 cubed, 4 times 4. Okay, 4 times 4 is 16, so 16 is your actual answer here. All right, moving on. I'm going to skip these other problems and we're just going to solve for n. So this is like trying to decide what that exponent is. So it's like thinking about, well, how many times do I multiply 3 times itself to get 27? So 3 times 3 is 9. Right? If I multiply that by another 3, I get 27. So n equals 3. Sorry. Okay. N 4 times is 16. So something times itself 4 times is 16. Well, since 16 is not a very big number, I'm going to try 2. 2 times 2 is 4 times 2 more is 8. 8 times 2 more, oh, there we go, is 16. So n equals 2. Okay. Let's come down here and try number 17. Okay. 5 times itself, how many times? So 5 times 5 is 25. 25 times 5 is 125. So n equals 3 because I had 3 5s down here. All right, on to the next. A drawing to find the square units of each number. Remember, this is like area. This is like, you could think about area, right? If I had a square, it's like saying this is 8 by 8. Okay, well, 8 by 8 is 64. Okay, this would be like saying it's 12 by 12. 12, 12, right? You can fill in your whole box. 12 times 12 is 144. Okay, 11 times 11 look like this, 11 and 11, 121. Okay, well, square root is just the opposite of that. So when you think square root, what you're going to be thinking about is what number divides to equal that? What number times itself equals 16? Okay, so as I start thinking about what number times itself equals 16, the first thing that comes to my mind is 4. 4 times 4, 16. Okay, so you're just thinking about what number times itself, because it's only squared. So remember, square is 2. Square means 2, right? Two-sided. So what number times itself gets you that? And this is where knowing those basic facts comes in handy. 8 times 8 is 64. Last one, 81. 9 times 9 is 81. Okay, so moving on, we're going to talk a little bit about factors and prime factorization. Remember, when you talk factors, you're just talking all of the multiples of those numbers, and then the prime factorization is those most basic ones. So when I look at them, you can use a factor rainbow to do that, and then the prime factorization is those most basic units that would get you there. Okay, so it's thinking about those common multiples, your count by fours, okay, that kind of thing. So when you think about it, you want to think about how many factors does each number have, okay, and get those all matched up. And then you're going to pick your prime factorization based on that. Okay, I'm going to circle the common factors. So 12, I like to do the factor rainbows 1 and 2, 2 and 6, 3 and 4. Okay, I'm going to go back and put my commas in so that I know that those are different. 20, I always do 1 and 20, 2 and 10, right? 3, oh, sorry, it's 30. Let me erase here, guys. Sorry about that. I just looked down, up and saw that that was 30, not 20. Okay, put a 2 here, again, and a 12 here. Try 1 and 30, 2 then and 15, how about? 3 and 10. Okay, 4 doesn't go into 30, 5 and 6. Okay, so now I'm going to circle all the ones that they have in common. So 1, 2, 3, and 6. Those are the numbers that they have in common. Okay, so that would be thinking about the common factors, the numbers they have in common. Okay, we'll try another one later. Let's work on this next part. So the first 6 multiples of each set. So it's like these are count bys, multiples, right? The word multiple as opposed to factor. Multiple means multiplying by, so it's count bys. So 3, 6, 9, 12, 15, 18. Okay, 5, 10, 15, 20, 25, 30, so on. You're going to circle the one that they have in common. That's the 15. Okay, so least common multiple is what that is that you've just found. All right. So we're going to decide if these numbers are prime or composite. Remember, a prime number, only one in itself go into it. A composite number, multiple numbers will go into it. 29 you should see as prime. Composite, anytime it's even. Okay, an even number is going to be a composite number when it's a double-digit number. So that means this one's composite. This one's composite. Okay, well, let's think about 99. Well, I already know 11 will go into it, and 9 will go into it, so that makes it composite as well. Let's think about 83. 2 won't go into it, 3 doesn't go into it, 4 doesn't go into it, 5 doesn't go into it. This is actually a prime number. Okay, so when we think about prime factorization, I'm going to extend my page out here and show you the way that I like to do it. I like to take 24, and I do this little stair-step method, and the very first number I start with, if I can, is 2. 2 goes into 24, right? I get 12 out of that, and then I'm going to take 2 into that again. I get 6. So see, it's upside down division. 2 goes into that again, and I get 3. 3 is now prime. So all these numbers out on the outside are prime factorization. So the 24 is like saying 2 times 2 times 3. Or another way we could say it is 2 to the third power times 3. So that's prime factorization. Again, you always want to find, when you're finding prime factorization, the smallest number that will go into it. So I always start with 2 if I can. If not, I go on to 3. So for example, 27, I'm going to divide it by 3, right? And when I do 27 divided by 3, that's my starting point. So if you guys want to pause the video and go ahead and start working that out and finish that one, that'd be great. Okay, welcome back. You should have found that this is 3 times 3 times 3, or 3 cubed. Okay, either way is fine. Let's try 30. 30, right? We're going to take 30. 2 goes into 30. I get 15. 2 does not go into 15. 3 does. I get 5. All of those are prime numbers. So 30 is 2 times 3 times 5 in prime number factorization. Okay. That's it for today. We'll review prime factorization some more tomorrow.